Okay, so we are on slide 3, title slide +1, then we're to 3. And so we're talking about the neurotransmitter substances, 4 different neurotransmitter substances that are going to be amino acids. Not amino, not, based on amino acids. Let's just call it that. And so we're going to have glutamate, and aspartate. And so glutamate and aspartate are associated with learning and memory in the central nervous system and in the peripheral nervous system. So they're going to be associated with learning and memory in those 2 portions of the nervous system. Central nervous system being the brain and spinal cord, the peripheral nervous system being the cranial nerves and spinal nerves. And those 2 are going to be excitatory. So it's going to result in learning. Now we have 2 others that are inhibitory, and these are going to be GABA and glycine. And GABA stands for gamma amino butyric acid. And so you have to have both things that are stimulating to, or we do have, maybe I shouldn't say have to have, we have neurotransmitter substances coming from partners that are leading presynaptic neuron partners, because all these neurons are communicating with each other. So the presynaptic partner can be one that is pushing you towards action potential or inhibiting action potential. And when we're talking about glutamate and aspartate, these are involved in learning. Now, the inhibitory, it's a little bit hard to understand inhibitory neurotransmitters when we're talking about learning, but when you talk about some other things, sometimes you can understand it just sort of slows the process down. And so when we talk about some stuff later on, we'll talk about how people can be shaky or whatever, and that's where you don't have enough of the inhibitory neurotransmitter substance. So the GABA is the gamma amino butyric acid, is the principal inhibitory neurotransmitter for the central nervous system, and glycine is the principal inhibitory neurotransmitter substance associated with learning, found in the peripheral nervous system. Okay, so when we talk about these things like glutamate, so we've said glutamate and aspartate are the excitatory neurotransmitter substances. What are they going to do? They're going to be depolarizing, right? So we have to think about sort of the mechanics behind this. So what is it going to do? It's going to open positive ion channels. In this case, it's going to be calcium plus. It's a positive ion. And so it's going to move it towards action potential. And you can even go to places like GNC, some of these kind of places, and if you go in and you say, I've been forgetful, they'll say, here, get some glutamate and take it. And, so there are things like that you can buy, literally. Whether it really helps with memory, I don't know, but it is the neurotransmitter substance. All right, so when we talk about these 2 inhibitory neurotransmitter substances, they're going to be opening a different kind of ion channel. So when we talk about GABA, we can say it's going to open an anion channel. It's going to open a chloride, Cl negative. And that means that it goes from -70, and working its way towards -71, -72. It's moving away from action potential. So I said it's a little bit hard to understand this. There are some drugs of abuse, the so-called downers, barbiturates, sleeping pills. That they have their effect by enhancing these the GABA presynaptic partners, and so they make you sleepy, right? So barbiturates enhance the activity of GABA, and this is what I was thinking about. Yeah, sometimes, especially in the movies, you'll see there'll be somebody who's an alcoholic, and they'll be like really shaky, and they need to have a drink to so that they aren't so shaky, and so it ends up the inhibitory neurotransmitter substances. One of the things they do is they kind of slow down all of this, and so it ends up that alcohol abuse is going to the wording is that it renders the GABA presynaptic neurons, it makes them less sensitive, so they're less active. So people that are chronically abusing alcohol have to have the alcohol to be able to relax enough. I think of the shakiest gun in the West, some old movie, but I don't think he was an alcoholic. But anyway, Don Knotts. That's why people who drink a lot have to drink in order to relax. It's because it interferes with GABA. We have another neurotransmitter substance that is inhibitory, that is one of these amino acids, and it's glycine. Now, the GABA is in your central nervous system, right? So we had said it is the principal inhibitory neurotransmitter substance in the central nervous system, and glycine is the principal inhibitory neurotransmitter substance in the peripheral nervous system, in the spinal nerves and those kind of things. And again, it's going to be inhibitory, so it's going to be opening chloride negative ion channels, right? So to understand this, there are some poisons out there. There's poisons. There are two different poisons that we can talk about: strychnine and tetanus. Tetanus is a toxin from Clostridium tetani, right? And strychnine is just, you go wherever it is you go to buy poison, and I don't know what the heck, maybe rat poisoning, but I don't think it's used in that. But anyway, any kind of a poison. So what does it do? It blocks strychnine. When we talk about and tetanus, what it does is it blocks the inhibitory side of the neurotransmitter substance. And so if you think of breathing, and we're talking about, you depolarize to contract and then relax so that you can breathe. Well, if you inhibit the relaxing part of it, it kills you. and so these are very important that way. So the strychnine and tetanus is going to interfere with the presynaptic neuron partners that are slowing this process down, so that your muscles, especially in breathing, can relax, so that you can then fill and ventilate your lungs, and that's how they kill you. We'll come back with the next video blog, and we're going to talk about something called monoamines. And monoamines are very important in psychiatry, I guess you would say, treating emotional problems. They're associated with emotions. So we'll be back to talk about monoamines. And if you know anything about the categories of drugs that they use to treat mental type conditions, they often will be MAO inhibitors, monoamine inhibitors. So we'll be right back to talk about these monoamines.